So moving on to Pure 2, chapter 8.2, which we are looking into parametric with trig identities. So now there are no notes for this chapter because we're going to use what we've learned before about trig identities and parametric equation, what we've learned in chapter 8.1. So first, there are some useful trig identities you can remember for this chapter. So recall, there are a few of them. The first one is sine squared a plus cos squared a equals 1. Next one is that 1 plus tan squared a equals sec squared a, and 1 plus cos squared a equals cosec squared a. Okay. Now we're going to use this for parametric equation. So what are parametric equations again? Parametric equations are usually come as a pair. Okay, x equals and y equals, and then linking the x and y has what we call a parameter, a t. Okay, so t is the connection between x and y. Cartesian means an equation without the parameter t. That means there's only one equation linking x and y. So previously, 8.1, what we've learned is in order to create a parametric equation from a in order to create a Cartesian equation from a parametric equation, we've learned to make t the subject. Like the previous practice, we've learned to make t the subject, and then we sub into y, and then voila, we get a equation with just x and y without t. But in trig, it's tricky. Okay, pun intended. Well, why? Now let's see. Okay, now I'm going to show you the wrong demonstration to show you the right wrong working out. Now why? Let's say we start from x equals sine t plus 2. We'll try and make t the subject. So x minus 2 equals sine t. Now to make t the subject, we're going to inverse sine on the x minus 2. Here comes the problem. Now if we try substitute to the y, so y equals cos t minus 3, we are going to try substitute this t into here. Something disgusting reminds me like of a pickle in a burger happens. Well, why? Cos inverse sine x minus 2 minus 3. I replace the t with this. So cos of inverse x minus 2. That's vomit. That's disgusting. That shouldn't be happening. So what can we do? So therefore, there's the wrong way. Okay, so we're definitely not going to use this way. So how do we do that? What do we do? Well, let's cross it out. Okay, oops, sorry. Let's cross it all out. So what should we do? Well, we're going to use identities. Okay, we're going to use identities. So the identity that we're going to use is the first one, sine squared a plus cos squared a equals 1. Well, how? We'll make sine the subject first. So we're going to perform we're going to use identities in order to do that. So x equals sine t plus 2. I'm going to make sine t the subject in here. So x minus 2 equals sine t. Okay, just like me writing, I need to have some snacks when I revise. Okay, like when I revise, I need to like to put the subject on the left hand side. Okay, revision, snacks, subject, left. Well, same. So sine t equals x minus 2. On the other hand, on y, I'm going to do the same thing, but I'm going to make cos t the subject instead. So y plus 3 equals cos t. So cos t equals y plus 3. Next, speaking of snacks, we're going to use a recipe like food. We'll make a recipe. The recipe is, so we're going to use sine squared a plus cos squared a equals 1. So that's a recipe that being called upon. So that's your sine t. Oh, that's your sine t, and that's your cos t. So we can use identity. So recipe call for sine squared a. That means sine a squared. So x minus 2 squared plus cos squared a. So cos a, which is y plus 3 squared equals 1. So can you see? This is my sine a or sine t, and there's my cos. Wrong color. And that's it. Okay, so that's a Cartesian equation. That's the answer. So how do we know that's a Cartesian equation? Well, there's no more t on there. So there's no more t. So all we've got is just x and y. So that's Cartesian. That's finished. All right. Now, part B, hence, sketch a curve. Hence. Well, the word hence means, use the answer in part A. In part A, we've changed it to Cartesian. So part B, you tell me what shape is this? You should know. Yes, Dora the Explorer tells us a circle. So radius is square root of 1, which is 1. The center of circle is 2, -3. Therefore, we can sketch it quite easily. 2 minus 3 is here. And that's the answer. 2 minus 3. That's the answer. Okay, right. 2 minus 3. And that's the answer. Right? Next one. Example. A curve is defined by parametric equations. Again, x equals sine t and y equals sine 2t. Find a Cartesian equation of the curve in the form of y equals f of x. State the value of the constant k. 2 questions in 1. Okay, cheeky. First one is make a Cartesian equation. Second one is find a constant k. If you know this k value in here, they're asking you for the domain. Okay. With that being said, to find a Cartesian equation with a trigonometric parametric equation, oh my tongue, need a massage. Trigonometric parametric equation, we want to use the identities. Okay, x being sine t, there's nothing else we can do. Okay, but y equals sine 2t. So let me rewrite x equals sine t. I'm going to just make sine t a subject. So sine to the left. Okay, just switch it. On the y equals sine 2t. Now sine 2t double angle formula. Sine 2a is the same as 2 sine a cos a. Well, what else have we got then? Okay. Well, before we use identity, hopefully you realize sine t equals x. There's also a sine t, so we can replace a sine t into y equal 2x cos t. Okay. Next, I'm going to make cos t a subject. So y over 2t equal cos t. So cos t equals, oh, not t, sorry, it's meant to be x. 2x. Okay. Again, how do we, it's all about thinking in here. In maths, it's never about remembering steps, but it's more about understanding why. Okay, what triggers our process? Is that when we're hungry, we go to eat. When we are revising, we go to eat. When we're sleeping, we're thinking of eat. We're thinking of snacks. Okay, when we're in a lesson, we're snacks underneath the table. Okay, chewing gum, whatever. Okay, when we do maths, we think about that, working out why. So the reason I'm doing all this step is because when I want to change a parametric equation with trigonometry in there, I need to use identities. And to use identities, I need to try to break it down as much as I can so I can use identities. One identities I can use is sine squared plus cos squared. Knowing sine 2t can be written as 2 sine t cos t, that's a logical thing to think of. Sine 2t, what can we do? Well, 2 sine t cos t, there's only one thing we can do. So, and then therefore we see a cos t in there. So that triggers you to think about using identity, sine t squared. Sine squared t plus cos squared t equals 1. So next step, we're going to use sine squared t plus cos squared t equals 1. So therefore, x squared plus cos t squared. So y over 2x squared equals 1. Next, what can I do? I just expand the bracket. So x squared plus y squared over 4x squared. Don't forget to square everything in that bracket equals 1. What are I doing there then? I actually make y the subject. The question was y equals f of x, so I need to make y the subject. So here comes the challenging thing. How can we do it first? Well, to make y the subject, first of all, we want to get rid of fraction. Okay, no one likes fraction, right? No one likes fractions. So we're going to multiply everything by 4x squared. It's like one of the cousins that come to visit your house and take all your snacks. Okay, these cousins are unwanted, just like fractions. Just call them fractions from now on. So times by 4x squared becomes 4x to the power 4 plus y squared equals 4x squared. To make y squared subject, I bring it over. Now on the right side, I see a lot of things that could be factorized, so I can't help to factorize it. Okay, it's like you see a bag of Starburst, you can't help to dip yourself with one of the purple ones, or the red ones, or the orange one, just not the green ones. So you factorize 4x squared becomes 1 minus x squared. Then when I square root, I get 4x squared, 1 minus x squared. So next, now there's a plus and minus, you'll be thinking, because when I square root, there's a plus and minus now. But we don't have to use the minus in here, okay, because t is between minus pi over 2 and pi over 2. So when t is between minus pi over 2 and pi over 2, sign is always positive. So therefore, it's always a positive. Now, when square root the 4x squared becomes 2x. So it's 2x square root of 1 minus x squared. Can you then rewrite it as square root 1 minus square root x squared? No, you can't. Okay, so remember, when you square root the minus inside, you can't break it out. So that's the answer for part A. Right? We next need to find the domain. So what's the domain? To find the domain of x, domain of the parametric, hopefully you've learned from last lesson. To find the domain, have I done it in here? Yep. Part A, just like part A. To find domain, I use x equation. Well, why? Because domain relates to x. So to find domain in a parametric equation, I'm going to use the x equation. Okay, so to find domain, I use the x equation. So what's the x equation? Well, x equals to sine t. Now, sine t is between minus pi over 2 and pi over 2. Think about this. Draw a graph of sine x, sine t, this one for t. Next, sine graphs like this and this. I only want the part between pi over 2 and pi over 2. So therefore, pi over 2 is here, right? So only up to here. And minus sine pi over 2 is here. So therefore, yep, so therefore, you can see the value is minus 1, oops, is between minus 1 to 1. Therefore, domain, okay, so therefore domain is minus 1 to 1. And that's the value of k, so k equals 1. All right? Part B, hence find the range of k. Range, we've used x to find the range, use y. Well, simple. So find the range, part B, to find the range, we're going to use the y equation. So y equals sine 2t. Sine 2t, where t is between minus pi over 2 and pi over 2. So this is a transformation of graph. So we've got t and y. Originally, it's like this and this, because up to pi over 2 and negative pi over 2. Now, when you 2 times inside bracket means we're shrinking 1 and minus 1. We are multiplying x coordinates by a half. In other words, we'll have a graph like this now, because that becomes minus pi over 4, that's pi over 4, and that's pi over 2. However, you can see on the y-axis, the 1 and minus 1 remains unchanged. Therefore, the range is still minus 1 to 1, and that's the answer. All right, so that's how we find domain and range. Domain, use the x equation. Range, use the y equation. When it comes to trigonometric functions, use the graph. If it's like a previous one, okay, where you can't sketch a graph like these ones, then what we can best to do is we can best to find the values in there, see what pattern we can see in numbers. All right. Next one. Oh, it's a practice, okay, or to you. Okay, pause the video, have a go at the question. Okay, when you're ready for the answer, you can press play. Right, so here comes the answer. So the answer is y equals x squared over 2 for the Cartesian equation, and k equals 2 with the being the domain. So if you got it, well done, move on. Okay, next practice. If you don't, I'm going to explain step by step how we do it. So first of all, to find a Cartesian equation, I'm going to start by writing the x equation, which is x equal to sine t. Make sine t a subject, so x over 2 equals sine t. So sine t equals x over 2. On the other hand, for the y equation, y equals 1 minus cos 2t. Now you have to recall cos 2t has 3 variants, cos 2a. We want to use the one with the sign. Well, why? Because x has a sign in there. So y equals 1 minus, being 1 minus, put a bracket, 1 minus 2 sine squared t. So cos 2a equals 1 minus 2 sine squared a. I explain again. Reason I use this version 1 minus 2 sine squared a is because x has the sign in there. Okay, therefore there's no reason for me to use 2 cos squared a minus 1. So yeah, okay, so expand the bracket. So y equals 1 minus 1 is 0, gone, minus becomes a plus 2 sine squared t. Well, I don't need to use any identities in this one because I can see sine t being x over 2, that's my sine t. So I can now rewrite y equals 2 times x over 2 squared because that's my sine t. So y equals, expand bracket, x squared over 4. So y equals 2 times a quarter is a half, so x squared over 2. And that's the answer, right? Part B, define domain. Okay, define domain. Define domain, I'm going to use the x equation. So I'm going to use x equals 2 sine t. Well, t is bound between minus pi over 2 and pi over 2 again. So t is between pi over 2 and minus pi over 2. That means if I sketch a graph of t and x, like this again, pi over 2, negative pi over 2, 1, and minus 1. 2 sine t. So x equals 2 sine t. 2 sine t means I am multiplying the y coordinates by 2, transformation. So I'm going to be a bit lazy in here. 1 becomes a 2, minus 1 becomes minus 2. Therefore, the domain, which is about the x value, so you can see the x value is on the y-axis, in the vertical axis, the x-axis, 2 and minus 2. Therefore, that's the domain. X between minus 2 and 2, right? Next one, okay, pause the video, have a go at the question. When you're ready for the answer, you can press play. Right, here are the answers. Okay, question A, question B. If you got it right, again, well done. Time to do more, do my homework. All right, enjoy and have fun. Don't forget the snacks. Right, if you don't, let's go through why. So question A, first of all, cot and cosec squared, you can see an equation that prompts you to think about using identities about 1 plus cot squared equal cosec squared. So with that in mind, we can make cot and cosec the subject. So x equals cot t plus 2. To make cot t a subject, I move 2 to the other side, equals cot t. So cot t equals x minus 2. Right? On the y, I'm going to make y equals cosec squared t minus 2. Move the minus 2 left-hand side, becomes plus 2. Now, and then if I put the cosec squared left-hand side, y plus 2. So, sir, why don't you make cosec the subject? Why do you leave the squared in there? Because remember, I know in my mind already, I'm going to use 1 plus cot squared equal cosec squared. And there's a cosec squared in there. So there's really no point to make it square root on the other side. Okay, so therefore, I'm going to use 1 plus cot squared a equals cosec squared a. So 1 plus cot squared a, so x minus 2 squared. That's your cot t, so that's cot t squared. Plus equals cosec squared a. Cosec squared already same as, so it's the same as y plus 2. I'm not squaring because you can see it's cosec squared, so there's no point squaring. Squaring, English. Next one, I need to make y the subject. So I'm going to expand the bracket in here. So x squared minus 4x plus 4 equals y plus 2. Bring the minus 2 left-hand side. So 1 plus x squared minus 4x plus 4 minus 2 equals y. Put the y left-hand side. So x squared minus 4x. 1 plus 4 is 5, minus 2 is 3. And that's the answer. Okay. Next one, domain. To find domain, I'm going to use the x equation. The x equation given to me this time is cot t plus 2. So x equals cot t plus 2. And I know, and t was given between 0 and pi. So cot t, that means you have to recall the cot t graph. So the cot t graph is this. Between pi and 0. So that's the graph. Now that's the graph of cot t. So x equals cot t, that's x and that's t. Now, if I have to add 2 plus 2, means I move the graph up by 2, so move it up by 2. Move up by 2, it doesn't make a difference because, I mean, it does visually, but in terms of the x values, in terms of the x, which is vertical values, you can see we're covering all the values from there, all the way there. So therefore, the domain is x belongs to all real numbers. Okay. Right, so that's pi. Part B, sketch graph x squared minus 4x plus 3. So part B, y equals 4x x squared minus 4x plus 3. This is a quadratic graph of the y-axis being 3 and 1 and 3 in here. I think I copied somewhere where the minimum point. You don't really need the minimum point. Okay, so 1 and 3. Now, can I draw a whole graph? I can. What I'm trying to say is, why do I have to draw a whole graph? Why do I do this? Why might be drawing half a graph or some part of the graph? You'll see next lesson. But the reason being is I can freely draw the whole thing without any worries because x belongs all real numbers. That means I can sketch a whole graph. X belongs to all set of numbers, so I don't have to limit myself to draw part of the graph. In chapter 2, I believe you would have seen disjointed graph like this, maybe something like this, yeah, or maybe like this, yeah. So these graphs I would call, for example, if I told you t at 2 to 5, that means the domain of this graph is between -2 to 5. So my domain is not everything. That domain, I mean, my domain doesn't include all real numbers. If my domain means all real numbers, that means I can draw the whole graph without worry. But because this particular graph has a domain of -2 to 5, therefore I'm going to draw part of the graph. In our question, our domain is all real numbers, so that's fine. Okay, so the whole real graph. Right, and that's chapter 8.2.